Hi, hello there, lovely one. So we're going through questions from a grade 10 paper 1 end of year exam, and over here we have a factorising question, and I put my little list of things that we can use, tools we can use when factorising, starting with common factor. That of course includes grouping, then difference of two squares, trinomial, and then the sum or difference of two cubes. Believe it or not, that's meant to be a cube. So let's take a look at this over here, and what's interesting is we actually have 1, 2, 3 terms. So it implies that grouping's not going to happen, but may still be a common factor. So let's look. The coefficients on each one. There's nothing common about 3, 2, and 5. Do they each have a p? Well, that has a p, that has a p, but there's no p there, so p's aren't common. There are no q's that are common, but these brackets are really interesting. A minus b, b minus a, it's almost a minus b, and then we've got a minus b. Great thing about maths is if we see something we don't like, we can change it. And this particular process we refer to as changing the sign. But literally what we're doing is just taking out -1 as a common factor. So that turns the minus into a plus because negative times a negative. And that of course means we can do that. And now, while we look at it, we can start seeing a common factor. Once again, highlighters are a very important tool. You should always have one in your pencil case. If we highlight the common factor, it's a lot easier to see what's left behind once we've taken it out. So there we go, and in brackets we've got 3p squared left over, and then we've got 2pq, and we've got minus 5q squared. So we've factorized this bracket as much as we can. However, over here I can see that we can possibly do a trinomial. There are no more common factors, there's no difference of two squares, but a trinomial might work. Everyone uses a slightly different method to figure out a trinomial. I like to use this method where I draw a nice little cross and then I put the factors of the first and the last term in over there. And then, so 3p times p gives me 3p squared, and then of course 5q times q gives me 5q squared. You'll notice that I haven't paid much attention to the minus just yet. I am going to put that in later on. Okay, so let's go through this then. We've got p times by q is going to give me 3pq. And then I've got p times by 5q, that gives me 5pq. And what am I trying to get? 2pq. I know one of these has to be negative. So is there a way to get from 5pq and 3pq in order to, to get to 2pq? The answer is yes. If it is minus 3pq, then I will get to 2pq. In other words, that q needs to be negative. So in terms of my brackets for factorizing my trinomial, I am going to have this as a bracket. So it's going to be 3p plus 5q. And then the other bracket is going to be the bottom two, which is p minus q. Pretty complicated question, not difficult, but just complicated. There's a lot going on. Anyway, that's enough from me for now. Much love.